Rich Turner is on the group that's bringing Agile methods into the DoD, or struggling to bring Agile methods into the DoD. And his background with both big-scale process improvement in industry and in development, and as an analyst in private industry makes him eminently suited for that. So give him a big hand and we'll enjoy the talk.
Okay, can you hear me? Thank you, Michael. Thank you, Doug. Thank you, Brian. Thank you, Terry. Thank you, everybody, for inviting me. I appreciate this. Oh, wow, lots of people. Lots of people. One of the things about the introduction, I was not the primary author on the PMI extension for software engineering. I was one of about 12 core authors. It spent a couple of years trying to put that together, and thanks to the PMI and to IEEE that we got that done. If you haven't seen it, it's an interesting piece of work. PMI is beginning to understand that everything is not predictable and that everything doesn't necessarily have to happen at the beginning. So if you get a chance to read through that, it's keyed to the 5th edition of the PMBOK guide. Okay, so theme of this conference is bridges to quality, right? So I thought I would try to take that bridge metaphor a little bit farther, and I would talk about using that as a metaphor for what we need to do to bridge from software engineering to systems engineering. So I think this is critical. It's something I've been working on for the last couple of years, and I think it has a lot of reasonable impact on all the software folks out there, as well as the systems engineering folks. I think it's a two-way street. And we'll talk about that as we go on. My guess is that most of you here will know something about most of what I say. What I hope to do, though, is to provide you maybe a different viewpoint into it, or maybe connect some things that you hadn't thought about connecting. So that's my goal here. I have to do my advertisement a little bit. I work for the Stevens Institute, but my research that I do is through the Systems Engineering Research Center, which is a university-affiliated research center at Stevens. It's actually led by Stevens. And the idea, it's funded by the Defense Department. All the UARCs are. Johns Hopkins APL is a UARC, so you can see the difference there. Anyway, it's a little different from most of the UARCs in that we are 20 some odd universities. I think the current number is 23. I'm not sure this slide's up to date, but we're pretty much all over the country. We are missing some of the Pacific Northwest, but we'll work on that. But there are lots of good folks there. Most of the research that I'm doing now, I'm doing with USC out in California and with Auburn University down in Alabama. And that research is basically on trying to figure out how to get systems engineering and software engineering talking to each other. So that's kind of what I'd like to talk about. First, I want to sort of talk about the problem as I see it. And again, this is something that you all probably deal with every day, or at least some of you do. But I'd like to at least kind of focus in on a few parts of it. Give a fairly quick discussion on what I think the fundamentals of successful system development are, and I'm going to take it from a couple of different perspectives. Then I want to try to take the idea of the bridge and discuss what we can do to balance things out in a bridge across these two disciplines. Then including and to kind of conclude with a description of a new old framework that has been evolving for the last 25 years that we think is in a new place and offers some new insights. And then at the very end, talk a little bit about what all this means to us and what we see and where we're going. So that's the agenda. I don't know how many of you, probably most of you, saw The Lord of the Rings, right? First thing out of anybody's sound system was, the world is changed. I had the sound clip, but it didn't seem to work. I'll actually plug this in for another something later. Anyhow, those four little words, and all the music underneath it just kind of brings in this anxiety. What's going on? Why is the world changed? Why do I suddenly feel like I'm in a different place? Why is it that everything I learned 6 weeks ago doesn't seem to apply quite as well as it did 6 weeks ago? This is the issue. And I think for the last few decades, systems developers, software developers, all of us have kind of felt that we were sort of on top of a wheel and it was spinning, and we kept going, but we had to keep going because if we didn't, we'd fall off the wheel. And it's a horrible feeling. And they talk about this idea of dis-ease as being sort of a zeitgeist of our time, that there's so many things going on and so many things changing that we don't know what to do with it. But whether or not we really think that that's a psychological issue or not, the fact is that in technology and in software, this is true. Things are changing very, very rapidly, and it really has an impact on the systems that we build. Now, there's some examples here of some of the issues that we're facing that we didn't really think about. I guess you can pretty much make them out yourselves. But I think there is a sense that we're trying to grapple with technology, with complexity, with interdependency between all of these problems. And it's tough. We see failures around us. We see spaceships crashing into planets instead of landing on them. We see software going out that's not quite right and causing great harm and great damage, both from a personal set of interactions as well as political interactions. And this kind of feeds the anxiety, the 24-hour news cycle, all of that good stuff. I don't know about you guys, but this whole Ebola thing is just really, I don't know what to do with it. I've got a daughter who's a critical care nurse, and she's saying, don't worry about it. We can take care of this. This is good. But nobody else seems to want to leave that, particularly the news and the media. So I think there are realities, and then there are spun realities that we always have to be aware of. Anyway, so where does this leave us in software engineering? Well, for one thing, we end up with this idea that everything has to be done immediately. Our customers want things yesterday. Well, they've always wanted things yesterday, but now they kind of expect it, right? So we've gotten shorter development times. We're getting more and more requirements that are of the icky-wizzy form. I'll know it when I see it, which is a great thing to try to build against. Yeah, rocks, right? Management by rocks. Is this the right rock? No. What kind of rock do you want? Well, I don't know. I'll know it when I see it. Bring me another one. All right, so there is these things that are happening that are changing this stuff. So, and the other thing that I notice as a teacher is that the materials in my courses changes much more rapidly, particularly if I'm teaching industry courses. You know, you can get away with the students. They're not dealing with quite the same pressures that the industry is. But you get industry students, if you're not teaching them things that are especially and particularly important to what they're doing, they go off and they're going to do their work in their heads anyway. So there is this sense of even the professors are taking a while to catch up. All right, so when I talk about traditional development, understand what I'm really talking about is what we all, or many of us, learned in school. It's really the standards, it's our body of knowledge, the management paradigm that we grew up in. There was a statement by an MIT professor that he was embarrassed with the MBA program at MIT because everything they taught was of no value to the people who were actually going out into the real world. Okay, so change it. Well, no, we can't. But anyway, there is an orthodox product development management approach, and I think Don Reinertsen, who most of you probably, or if you haven't read his book, you should, Principles of Product Development Flow. I'll hawk it again and again because I think it's a very, very important book. Anyhow, he talks a lot about the wrong things in our orthodox and development management approaches, and that we focus on things that are of no value while ignoring things which are of great value. So I think that's kind of interesting. But given all of these disconnects and all of these problems and all of the traditional development and where we're going, and you can sort of, I don't need to go through each of these, I think. But I think one of the key issues is, and I would say that it is the characteristics of software that drive this. And I know it also is Moore's Law and things that enable software, but Moore's Law by and of itself really doesn't do it. It's us taking advantage of Moore's Law that's driving this stuff. So I think we are, as software engineers, partly responsible for the world we live in software development. Okay, so let's talk a little bit about systems engineering and software engineering. And I'll throw the water bottle down. Systems engineering, unlike software engineering, tries to take a more holistic view. So how many of you have either are systems engineers, know a systems engineer, had your brother marry a systems engineer? Anyways, has systems engineering connections? Oh, good. Oh, okay, so I don't have to spend a lot of time talking about systems engineers. Now, we're talking about systems engineers not from the term of like a Microsoft systems engineer, which is a very narrow focused thing. We're really looking at people who are trying to put together complex systems, okay? So there's a very short history of systems engineering. It started in general systems theory back in the 30s. Then Bell Labs coined the term back when they were trying to do all those cool switches that they were doing, mechanical switches. They were having to shift over maybe to some automated switches. In the NASA heyday, systems engineering was the big word. That was the big thing, and we'll point some things out there. And today we still have the V model. We have systems engineering being applied to lots of different things. Singapore uses systems engineering to actually run its economy. It's kind of interesting when you look at that. I'll leave that for you to investigate, but it's a fascinating way of doing it. On the same time, we have a little bit of a short history of software engineering here. This is taken from a paper Barry Boehm gave at ICSM, and he basically tried to do it in a Hegelian way, right? Barry's kind of a philosopher at heart, and he looks at it as in terms of thesis and antithesis, etc. In any event, we start off in the 50s, software engineering was really like hardware engineering. It really was, because it was a bunch of hardware engineers that were writing algorithms in software. Then we got into software crafting, where they figured, well, software really isn't like hardware, but we don't have anybody in engineers that can do it, so we'll take sort of anybody that comes in, and you begin to get that cowboy programmer kind of idea. That was the hero. We started to try to say, well, how do we fix that? And we come up with the waterfall processes and Winston Royce's poorly drawn diagram of the waterfall process. We then move on into the 80s, where we actually get some tools supporting all of this good stuff. We get productivity, some creativity out there, some scalability, but not a lot. Against that, we then come up with this idea of concurrent versus sequential processes, which is really difficult. And it's also, this is where we begin to see the revolution against the process police version of process improvement, right? We have the priesthood here who's telling you how your processes should work, and then you had the people on the ground who are saying, yeah, but they don't fit. And this was difficulty. And so what happened? We had our Agile Revolution, and I still think that 90% of the Agile Revolution was psychological and emotional, not so much technical, because all the technical stuff was there before. If you really think about it, it's not new. It was just people fighting back. It was people having confidence to say, I'm not going to do it this way because this isn't the best way to do that, which I think is great. And we begin to get this whole idea of agility and value and lean. And where are we now? Well, when we were looking at this, Barry actually made some projections for 21st century software engineering, and he left out a few big ones. He did not look at the fact that it would be ubiquitous software, that we would be carrying around huge computing power in our hands, and then we'd be using it all the time. So social media and that whole concept of everything being connected to everything, we really didn't foresee. But that does, in fact, provide this latest chapter of software engineering. So let's compare these two. How are they alike and how are they different? Now, this particular picture was from a presentation I gave on sibling rivalry, and I never said which was which. But depending on who you were giving the talk to, it was really interesting which they thought they were, the systems engineers and the software engineers. No one wanted to be the cow, by the way. In any event, so the similarities, well, these disciplines are both very young, right? So there's this idea that we don't have hundreds of years of mechanical engineering, of electrical engineering behind us. We have maybe 60, maybe 70. Identity. Get somebody to define software engineering for you, or systems engineering for you. My guess is that if you ask 5 people, you'll get 5 different definitions, and the only time you'll get really heavy arguments about them is by the people who wrote the definitions. So if you find that you're talking to someone who's a standards person, who actually was part of a standards process and know what you go through, they would be defending theirs to the death. The rest would say, oh yeah, well, you could look at it that way. So there's not a lot of identity here, right? In fact, we'll talk about identities in a minute as to what the media at least says. Practicality. We are not theoretical. We are practical. We are practitioners of a particular industry. Systems engineering does things. Software engineering does things. So there's not this continuous theoretical. I mean, we have computer scientists out there who are doing a lot of cool things with algebra and stuff like that, but primarily we are, in fact, practical, and we get no respect, right? I don't know about you guys, but in the government, the first thing that gets cut in funding is systems engineering, documentation, training, configuration management. You know, that should come out of your overhead. He was very right when he talked about, I have a slide on the DoD's approach to acquisition. I'll show it in the tutorial. Okay, so what are the differences? Education. Systems engineers tend to be hard engineers. They know all about differential equations and fluid mechanics and all of those kinds of things. Not so much the software engineers. They're like anthropologists often, people who couldn't get a job. At least in the 80s that was the case. I think it's better now, but still there is a wholly different perspective from the engineering perspective where you really have laws and physics and things like that to the software engineering where you really are dealing with very abstract things, right? We can talk about negative time. We can talk about, I don't know, things that go faster than the speed of light, right? But that's not quite the physics world. Values. Systems engineers value static things. They like baselines. They like configuration control boards. They want things to not change. Software engineers, because software is actually only valuable if it changes, right? We like change. So there's a whole bunch of, there are problems trying to get these guys to talk together. So we need a bridge. The other possible middle model is architects out there. Anybody a software architect? Okay, a couple. Anybody do hierarchical decomposition at any point in their life? A few old guys who remember that stuff? Well, that's the way systems engineers think. Everything is a part of something else, right? We start off with a system, and that system is made into subsystems. Well, software, we don't think about that. We talk about functionality. We talk about used by, right? So those two different concepts for architecture make it very difficult for the two disciplines to talk. Fundamental concepts. That was about as fundamental diagram as I could get. Didn't work. Okay. Yeah, sometimes the one I had up there before was worse, so don't. I'll give you a minute to kind of read this, but this is Berry's fundamental system success theorem. And it applies to any system, but particularly to systems with software in them, I believe. And that is, a system will succeed if and only if it makes winners of its success-critical stakeholders. Now, you have to kind of define stakeholders there, but stakeholders are people that literally have some impact on the system, or that the system has impact on, right? So if you think about an app on your phone, then the stakeholders could be anybody from the developers who are developing it, the people who might have funded that development who would like to see some sort of return on their investment, the people who use the app, and the people who might be impacted by the app, right? Well, now some of those aren't success critical, unless they've got some sort of power. So the success critical is really a political situation or a power knowledge. But if everyone significant is a winner, then there's nobody left to complain. And that sounds real stupid, but if you think about some of the complex systems, I'll throw out the next generation air traffic control system. Think about the number of very powerful stakeholders that you have there who have very, very different, very, very different win conditions. The pilots, the airlines, the controllers, us, My own feeling is they should make the seats in the airplane bigger. I think that's part of the air traffic control because it controls my ability to move through air traffic. Proof of only if. Nobody wants to lose. If you're going to lose, you may in fact refuse to participate and likely will counterattack. If you've ever been trying to do something, and how many of you think you're change agents? You think of yourselves as change agents? Yes, yes, yes. Okay, so have you run into the organizational antibodies? Whenever you come in somewhere and suddenly somebody sees you're doing something well and they immediately undermine you because you're doing something well and they aren't, and they don't want to change? Okay, so this is what we're talking about here. Usually that result is lose-lose unless you can find enough power to push that, those antibodies away or get rid of them, find some sort of antibiotic, I don't know, something. Anyway, so that's the success theorem that we sort of have put forward. And this was put out several years ago. Now, in order to make this work, then that means you have to make winners of all of your success critical stakeholders. Now, this means trying to figure out who they are, which is an issue, understanding how they want to win, trying to come up with a way to negotiate among themselves, and by negotiation, I'm talking about satisficing, not consensus, but satisficing. Success critical, negotiate a win-win plan and product, and then you control that as it changes. Now this is really interesting. This will be useful later on in the talk. But remember it, you will be tested. That's why I'm an academic. Okay, let's talk about fundamentals of discipline. When we talk about discipline, what do we really mean? We do not mean whips, chains, various things like that. No high heels. What we're really talking about things that underlie and improve how you are able to do something. So disciplines like practicing the piano, right? You practice scales, you practice chords, you practice various sundry etudes, right? That's to get your discipline down, to understand how you do things right. I was a singer for a long time. I still dabble in it, but I'm not trying to make money at it anymore. And one of the things you learned was when you were sick, you depended on your technique. Because if your technique was not sound, then when you were sick, it sounded like you were sick. Usually you could work through it if you had good technique. But experience, principles, alignment, how aligned are what you're doing. Those are all discipline-related things. And in our case, infrastructure, architectures, basic skills. All those things that we need to know to be able to actually do something. How about agility? Well, it's a little harder to talk about agility because it's really discipline in action. It's the ability to take a disciplined response and adapt it to what the world, what your environment needs, right? So you've got, what's the old story about if you're in the wilderness and you have a map and the ground doesn't match the map, ignore the map because you're on the ground and you'd best not fall off into that crevasse that's standing in front of you that isn't on the map. Well, that's what agility allows you to do. It allows you to turn left or turn right. It allows you to go with the flow, and flow gets to be kind of a spacey thing. People talk about, I'm in the flow. Quarterbacks get in the flow before they make the throw that gets intercepted. But anyway, flow, improvisation, adaptation, insight, and creativity are all what I consider fundamentals of agility. I don't mean this in the terms of discipline like a particular kind of software development or agility by being XP. What I'm really talking about is the ability to adapt and change. So that's my definitions of discipline and agility. Now, a decade ago, Barry Baby and I wrote a book on balancing agility and discipline. We took a lot of flack for the title, particularly from the Agile people, because they said, but we are disciplined. We said, we didn't say that. We didn't say you weren't disciplined. We're talking about not Agile versus something. We're talking about agility and discipline and the fact that you need both. Well, traditionalists came through on this side. I don't know if I have to go through all of these things. I think the big design up front is an issue. And this is basically now seen as the systems engineering way of thinking about things. Whereas Agilists were very much aimed at the rapid change, and they dealt with it very well. They dealt with emergent, vague, and volatile requirements because they were constantly involved with the stakeholders, right? because they were doing integration continuously, which is part of Agile. And again, when I talk about Agile, I want to be careful that you don't think I talk about Scrum. To me, Scrum is a Agile management technique. Okay, so just so that I don't see. One of the problems I have, can I take it aside here? One of the problems I have in the Defense Department with trying to figure out how to get more agility into what they're trying to do is that, oh, you want Scrum? Well, maybe. It's a good thing. We all think Scrum is a good thing. It's better than some of the other things, but it's not all that there is. And to do Scrum and to get the benefit out of it, you need to do the technical activities as well. You can't just manage that way. You actually have to provide the infrastructure and the technical stuff. So there's a good deal of people in a large bureaucracy like to have standard things. And so if they can standardize their concept of Agile to Scrum, and they know what Scrum is, then they're very comfortable with that. Managers are very comfortable with Scrum for some reason. I think they still think they have control over it, although I'm not so sure that's true. It shouldn't be true, but anyway. All right, so, excuse me. So anyway, so we had all these people on both sides, and they were at each other's throats. I mean, we really had some ugly, ugly things happening. And those things surprisingly continued on later, so I'm not sure whether we had any impact at all. But we did try to come up with a way of saying that, you know, there were home grounds here, that Agile was really good for some things, that you needed more traditional things for other things, and we really didn't satisfy anybody. That was not really what people wanted. They wanted a way. So we'll talk about the issue of a way in a minute. Actually, we'll talk about it in the tutorial. So the other conundrum was we do have these stereotypes, right? We got geeky white men with pocket protectors or systems engineers. Weapon-toting code monkeys. Yes? Is that frightening? I mean, and that's kind of the way it is. They're going to shoot up your bank cards. They're going to steal your identity. So we wonder, well, how do we get a carry law for something against the code monkeys? I don't know. That's something different. Anyway, these were the true believer types, and this is how they represented each other, right? I think this is more reasonable. These are who we are, unfortunately. We're fairly smart people who are trying to adapt to live in an organization or an environment that doesn't really understand us and that has very different values from what we generally seek. I think we're all in this together. Systems engineers, software engineers, everybody are dealing with the pointy-headed managers to some extent. All those managers out there, I'm sorry. I know you guys are the good guys because you're here, but just remember you have bosses somewhere. Okay, so where are we a decade later? 10 years since this book came out. Well, actually almost 11 now. We know that small teams are best. We know that. We understand that. We believe it. We've got ways to deal with small teams. However, we're just now beginning to get some ideas about how to scale that. And there are ways to do that. We've got scrums of scrums, which are good or bad depending on how you look at it. There's some other things that you do. Discipline is poor when implementing Agile practices. We still have people say they're doing Agile and all they're doing is just not documenting anything, not designing anything, not thinking about anything, just slamming out that code, right? Oh, good, good. I'm glad that there's some people that have, I get boos from some people when I talk about that. But it's true. It's true. I mean, you really do. And I'll be honest with you, I think when we get down to this, the software languages that we use now make this more likely. And we can talk about that if you want to. Agile management, falsely equated, we just talked about that. Okay. Software still doesn't speak business and executive management's language. Great example of this. Anybody here know anything about the future combat systems? You guys are sort of out of that realm, I think. I saw a hand go up by someone that wasn't sure they really wanted to let anyone know they knew anything about future combat systems. It was sort of a nightmare. It was a way of making the Army have a role in modern warfare. There was some sense that we didn't need the Army, we had the Air Force and the Navy. They could throw missiles and things at people and they could react quickly. And the Army was this incredibly huge bureaucracy that had to move all of this logistical stuff with them. So they decided they would do something called network-centric warfare. They would be able to, well, essentially it came out of the first Gulf War. I guess we're starting into the third, aren't we? Well, the first Gulf War, where they had the special forces guys on horseback, and they were running around and they were doing stuff and all. There was this there's very lightweight, very, very effective. So they said, well, let's just do that with the whole army. Now, it doesn't, in hindsight, why? Right? I mean, we look now and we say, this is dumb. But at the time, somebody thought it was a really good idea, so they did it. And we decided we would be a part of that, we being somebody that they hired us to talk through this stuff. Well, anyhow, so we were at this is multi-billion dollars over multiple years, right? And we had a chief of staff, Army chief of staff, that said, and it will be done by the end of the decade. No ifs, ands, or buts. I will not accept anything if it's not done. Again, okay, fine, you're a 4-star, you can say what you want to. Success critical stakeholder. Anyway, so we were at the first system of systems review, and it's in Long Beach, and it's in a Marriott or something down there, and we've got 800 of your closest friends sitting in a ballroom trying to do a technical review. Yeah, somebody's laughing, right? Do you think death by PowerPoint is meaningful? So we were sitting there, and you have to understand that the things that we were arguing about at that point were still sort of conceptual. Like what size the gun was on one vehicle out of 27, right? What size was the gun? Well, we had probably down on the front row here, we had 5 3-stars, a 4-star, a couple of 2-stars, and some 1-stars holding on to the what being the third stringer with the clipboard. That was it. It's early. The generals are all down there, and they're all sitting there, and they're arguing about, well, it needs to be this size because we've got all of this ammunition still here. We want to still be able to use it. No, it's got to be this size because it's got to make it big. It's got to have the right throw weight to be able to destroy this kind of thing. And then they would get off to, well, what are you going to have wheels or are you going to have tracks on these? The generals would argue about that. Okay, now remember, when you have to look at this concept, the concept is see first, know first, destroy. What lets you do that? The software. The communications between all these things are supposed to be sharing all this information. So what happens when the software architects get up there to talk about the common operating system that would be useful for this, that will defend all of these people that you're not giving any armor to because you want to drop them out of planes? Guy gets up there, very articulate, layered architecture, brick wall kind of diagram, sits up there. Within 5 minutes of his starting, the entire first 3 rows on the back had assumed the BlackBerry prayer position. There was no communication or understanding of what was being said to them, because it wasn't in their language. It didn't talk about the size of the gun. It didn't talk about tracks or wheels. It didn't talk about how fast you could get from one place to the other. It was talking about software. It was talking about layers, architectural layers, and all this technical stuff. So we share that with systems engineering to some extent, that we can't speak the business language or the executive's language. We tend to focus on small things, right? We think about test-driven development. We're doing unit tests. It's kind of what we think of when we do that, right? Or we're looking for a minimal marketable feature. Well, that's great, but how does that affect something like future combat systems, which is a truly software-intensive system, and yet from this, you can't go there from here. Flow and work in progress. We understand that now, right? We can talk about that. We can talk about limiting our WIP. It's not like we're speaking Greek anymore. Thank you, Don Reinertson. Thank you, David Anderson. But it hasn't really gotten up to the executive suite. It's getting there. Some of you Pacific Northwest guys, I know the net objectives guys have gotten into a couple of the executive suites. I think Dean Leffingwell has. Wariness toward explicit architectures. And this is a killer. If you're going to have a big system, you're going to have an architecture before you can start building anything, right? I mean, that's kind of a common thing. It doesn't have to be an ultimately specific architecture. It can certainly evolve, but you got to start somewhere. And this is actually being done surreptitiously in your software development environments, right? If I'm going to build something for Android, that architecture is established. No matter what I write, it's going to have to pass that sequence of tests or whatever. Same with Apple, whatever. You've got the architecture provided for you, so you don't have to build it. So you can say, oh no, I don't need an architecture. Size and complexity are still growing. Legacy software is exploding. You know, it used to be you'd get a software update every 12 months. Now you get one about every 12 minutes. And you better hope that Yosemite will recognize the last 12-minute update you had from your app. I just put it up this morning, so if it didn't work, I was going to use it as an example, but it did. But you know, that's the thing. All right, so enough of that. How about systems engineering? Well, we have been unable to get out of the V model. What we have is people playing with the V model. Everybody know what the V model is? You know, down one side, come the other. I saw some shake heads. God, you guys are lucky. Now, the V model has its reason. It's saying that everything you should do should be tracked back across toward the requirements, but it makes it look like you have to do everything before you get there, right? It looks like a triangle. So now we're getting multiple V's. We're getting V's of V's. Vis-a-vis this, vis-a-vis that, whatever. It's not good. We're stuck with it, and we haven't been able to really get past it. Systems engineering, these came out of, by the way, NDI, National Defense Industrial Association's 5 most critical problems in 2010. So only 4 years ago. So systems engineering decisions made without software input leading to poor software, generally because they're forcing the software to be some way that it's not very effective or efficient. You can't get the life cycles to work together. That's something that Barry and I have been working on for years. Stovepipes. One of the issues that we talked about on the first slide was that idea of being so specific about something and our knowledge being deeper and deeper and deeper. And so we get this sort of reductionist way of looking at things. And what happens then is you get this sort of local optimization that never makes it to the systems level. So that's an issue. We still have humans in these complex systems, and we still don't know how to predict what they're going to do. And they're getting more and more involved because the software is more and more dealing with them. There's no real answer for it, for building and verifying these complex systems. One of the issues that's come up is that all of our systems engineers are pretty much retiring. I say the industry. There's some huge number that are going to retire or are eligible to retire now. And they're hanging on for dear life, partly because they want to hold on to their values. And these young people coming along don't seem to share them. There seems to be a kind of a generational gap there. But it's really causing problems because we can't get enough people to do it. So people are looking at trying to fix that. And for some reason, systems engineering now thinks that all we really need is agile systems engineering, which on one hand is okay, and I will support that. But on the other hand is don't focus on agile, focus on making systems engineering fit the real world. If agile works, fine, but don't focus on that as if that were the panacea or that were the silver bullet. It may not be, right? There are other things out there that might work. Model-based systems engineering being one of them. Okay, so obviously we need to balance these things out. Our cone of uncertainty has that double nature. As we get more certain about the system, the environment is making the system less certain. So what we thought we needed isn't really what we needed. And Agile really works to this and to support that. Anything that gives you some chances to change and to steer the development is a good thing. We need software. It's critical to everything we do, but it really challenges abilities. All of the maintainability, reliability, security, safety, all those things are challenges to software. So they need to be looking at the systems level to be able to understand how they impact the abilities. Systems engineering needs to reconcile software values, and it has to be able to do all of these things that systems engineering is supposed to be doing, and it needs to do them in a new way or in new ways. So, what do we do with all this? I give you problems. I tell you what you already know. Well, here's the things that I kind of have collected over the years as being some of the components of success. And you know, it's not complete. It's not even particularly scientific. It's just basically what I think. Evolutionary development, I think, is key. Process flow with WIP limits and small batch sizes, we find the most effective way to get productivity from our software development teams. I truly think that's true. Truly think that's true. Okay. Short iterations, I think delivering value are important. I think a rolling planning horizon where you've got reality-based iteration planning is reasonable. Most of these things are pretty straightforward. I think learning is a big deal. I'm sort of the Singy world, that I think it's important for us to learn as we build systems. And I think Agile and Agility and Lean all allow you to, and iterative things allow that feedback that allows you to learn. I think architecture in keeping with the size of what you're doing, in other words, a rational approach to architecture, not IBM rational, but some approach. Collaboration, I think, is extremely hard to come about outside of small teams. I think collaboration across teams is very difficult. I think collaboration across distance is very difficult. But I think it's necessary. We need to work on that. Having multiple communication paths so that there's not this hierarchical up and down thing where if something happens here, it has to percolate all the way up to the top for somebody to do something about it, and then it has to percolate back down, and by that time, 5 other things have happened, or the whole project is stopped. So these deep supply chains. Demonstrable progress is key, and we'll talk about this later on with part of our new old way. Okay, so it's time to turn to the bridge metaphor. I'm halfway into my talk, and I finally get here, right? This is my attempt at high-level engineering. Two things. The bridge is made of the superstructure and the substructure. What does that mean? Well, substructure, I think, is what's there essentially to provide the ability of the superstructure to exist. And the superstructure is what allows the bridge to do what it needs to do. And I think those two things, whoops, let's go back. I think those two activities balancing each other are important. I think if the substructure is out of balance, then you could have an unstable bridge. Not good, right? If the superstructure is out of balance, not only could you have a not structurally sound bridge, but you could be having not enough of something, too much of something, all that sort of thing. So I think there's this balance is you get either an unstable bridge or an over-engineered and overly expensive eyesore. Okay, so both of these engineering disciplines have a discipline associated with them, and they're critical to the success. Bridge can't do anything unless it's connected to the solid ground, or at least something solid and weighty. And all of these things allow us to adapt that superstructure so that the traffic that is going to go across the bridge can be adjusted for, because the traffic's going to change. So it's important to maintain balance in construction between feature and fundamentals. So just as a quick break, I had to do this because we were so close to the actual event.
Dawn of a fatal day, and the wind begins to speak with a roar that no man can fail to hear. In a 40-mile-an-hour gale, the center span weaves like a ribbon in a swinging twist that you wouldn't believe possible unless you could see it as you do now. There's an automobile caught on the heaving roadway. The 11,000-ton center span twists and strains the giant cables that support it. Cables of 6,300 wire strands, each 17 inches thick. Back out of the danger zone, all stricken spectators are driven to safety as the bridge gyrates like a nightmare high above the river, twisting, turning, curling. The lone motorist is forced to abandon the car. He has but a few minutes in which to save himself. Face to face with fate, his destiny hanging in the balance. Will he heed the last warning or perish with the doomed structure? But he saved himself by seconds. No structure of steel and concrete can stand such a strain. Steel girders buckle and giant cables snap like puny thread. There it goes! Engineers are divided as to the cause of the disaster. Some claim it was the use of solid girders. Others differ. But whatever the reason, Tacoma will rebuild. This time a bridge that will not provide a super thrill in the news.
And we think our news is overly dramatized, huh? All right, how many people had seen this before? Most of you, right? How many of you think it was resonance that caused the bridge to collapse? Turns out it wasn't. I mean, resonance was a piece of it, but it turns out that they used these big flat girders instead of the lighter weight girders that were in trusses, and the wind hit the girders and had to go one way or the other, and it began to come up with something, what did they call it? It was, I have it in my notes. There was a cool name for it. Aeroelastic flutter. That's a good engineering term, isn't it? Aeroelastic flutter. Anyway, what happens is the wind was not resonant. I mean, it wasn't like it was at some special speed, but it was just enough that it made the things do this. And the reason you know that is because it was torsionally going. It wasn't going up and down like this. It was going side to side like that. Anyhow, sometimes one of the things that's interesting about this, obviously, I think a dog died. Somebody said a dog died. Somebody else said that the dog got out, but I think that was just wishful thinking. The guy left the dog in the car. Well, somebody went and tried to get it, but the dog bit him. Don't bite the hand that tries to get you out. Okay. Anyway, I think it's important because I think this is interesting. This was the guy that was one of the designers looking at the collapse, and he said that when we do new problems and we're looking at things where there is no theory or practical experience, we really have to rely on judgment, and a lot of times errors and failures occur. Now, to me, almost everything we do in software of interest is pushing those boundaries. Now, some of it's not. I mean, there are some things that we do that are not, but there are a lot that we are. And so I think that the discipline of these traditional analysis, architecture, and design is all great. But these bridge people did that. They did it to the best of the ability they could do. They did all the analysis work. They made all these plans. They actually were trying with these different kinds of girders to make it less expensive and built more quickly. Didn't work out. Well, in software, we're really lucky. We actually get to do that, and we don't generally have to spend thousands and millions of dollars building something that's going to fall down to find out about it, right? So a lot of the model-based stuff that we support is important. So I think that this idea of feedback and identifying risk is really important, and enough of the Tacoma Bridge. Okay. This is the new old framework. And I say it's new old or old new. I think Barry wrote the first spiral paper in '83. I think Vic Basili wrote a paper on iterative software development in '78, '79, something like that. So it's not new to think that we want to do things iteratively. It's not new to have this spiral model. What is new is trying to provide a set of principles rather than some diagrams. Too many people saw the original spiral diagram, which I did not put up there, but you've all seen, right, with the around, and said, oh, that's great. We just do a little bit and then we'll go back and fix it. Then we'll do a little bit more and we'll just sort of like, and what happened was the manager saw this and said, well, when does it end? All right, well, back in the around 2000, I guess, 1998, 2000, Barry added these milestones. Now, they were called anchor point milestones, and they were very similar to the RUP milestones. Not quite, but almost. Well, so then the Department of Defense gave us some money and said, let's see if we can't balance this out and put it within the Defense Department's framework. So that's where the evolution of this comes from. It's trying to go from what was a software development concept into one that's involved with systems development and actually systems acquisition. And it's based on things, well, there are actually 4 principles, which we'll talk about in a minute. But if you see, risk shows up a lot in here, and evidence shows a lot up in here. So those are really major issues, or major parts of this. And the idea at the top is that learning, that we are getting a cumulative level of understanding of the product, the process detail. And it is a risk-driven understanding. So there's lots of cool things in that diagram. But I just wanted to give you just a sort of a hint at it before we got into the definitions. So the incremental commitment spiral model is in fact a risk-driven framework, and it's a systems process generator, which is kind of an interesting thing, in that it's not a process. It is a way for you to build processes that meet the needs of what you're attempting to do. So one of our big hassles was trying to come up with something that wasn't a one-size-fits-all. And what do? We have a one-size-fits-all. But it's a different one-size-fits-all. This is, like I said, it's not a process, it's a generator. It helps you to understand how to go about building your systems by looking at the risks. There are 4 principles. We can talk through these again at a later date if you'd like to, but stakeholder value-based guidance. So 2 keys there. Stakeholders are important and their values are basically the guidance. And just the fact that value is put in there is a very good thing. Agile was really good about that. They were the first people to really talk about the value of a particular requirement or a particular feature. One of my goals in life is to get software looked at not as a cost, but as a value-producing enterprise. I think it would be much better if management understood that the software development teams were providing a continued source of value to the organization, that they were not a sinkhole for money that could be spent better somewhere else. So anyway, stakeholder value-based guidance, stakeholder in the stakeholders' terms. Incremental commitment and accountability, we'll talk about that in a minute. Concurrent multidiscipline engineering, don't just do the software over here and the hardware over here and the people stuff over there. Pull it all together and do it concurrently, which has its own issues, but it's critically important that it be done. And then finally, evidence and risk-driven decisions. Again, Agile fits in this beautifully because Agile provides evidence, right? We give working software every time we have an iteration. And it turns out that when we first were looking at this, we went back and looked at the Crosstalk Top 5 projects. Crosstalk's Air Force sponsored magazine, but they used to give out a top 5 software engineering or software acquisition project awards. So we went down and tracked, and they all, 60 to 80% of them used these. So that was good. Where's it based on? Well, it's based on John Boyd. All right, how many OODA loop guys out there? Everybody, anybody? 2, 3, 4? John Boyd was an interesting guy. He was the only fighter pilot ace that never fought in a war. He kind of came in between 2. But he decided that he created this whole idea of a observe, orient, decide, and act, which is still used to work on maneuver warfare, things like that is the basis for a lot of that stuff. So there is an origin there that says when you're developing a system, you're constantly going through these cycles of observing what the systems, or you're serving what you need to do, you're orienting what you're doing to associate with that, you decide what your next steps are, and then you act. And you continue doing this. And this can be done at a whole bunch of levels. And if you want to do a Google on OODA loops, there's 5,000 diagrams. It also looks a lot like some of the management cycles, plan, do, check, act, right? Anyway, so we integrate, here's the reason that we tried to pull the ICSM together. It integrates all these hardware, software, and human factors stuff into the system's life cycle. Right now, they're all separate and they don't really come together. It's developed in response to to clarify spiral development. You wouldn't believe the number of things that were called spiral over the years. It provided a framework for human systems integration at this National Research Council report, which is an interesting report to read if you ever want to. I've got the references, just get to me. Integrates strength of current process models, but not their weaknesses, and it facilitates, there's actually an electronic process guide that supports this thing. Okay, what's incremental commitment? Well, let's look at an analogy. Gambling. How many people gamble? This is engineers. None of you gamble, right? Oh, a few of you. How many of you play roulette? Why? Is it just the loving the risk, the being on the edge, the one roll and die kind of thing? Because that's what we do when we build software or we acquire software. We define all the requirements up front, we define all the plans, we fund it for a certain level and push the ship off the shore. Put it all together, wait and see if you win or lose. And that, as opposed to something like poker or blackjack, where you put some of your chips in, you check a few of your cards, you see what the other cards are out there, and you decide, do I want to continue this or not? Well, we feel like that's a much better way to develop systems. And that's what we're trying to do within this incremental commitment. If you come to the tutorial, there's some examples of how to do that. This is another one of those diagrams we don't like, because diagrams always get trumped, hopefully, by principles. But this is that traditional, stagey kind of way of getting things done. But the idea is that there's always going to be some upfront work for any system. Now, it may be done in 15 minutes over a napkin, but it's going to need to be done. And we've actually defined out what kinds of things go there and what kind of decisions that you probably need to make. And so you incrementally develop the definition of the system, particularly if it's a complex system, and then you incrementally develop the system and operate it. One of the things that most of the research that I'm doing now deals with systems that are already operating that are being constantly updated, constantly upgraded. Hospital systems is a good example. You got all these different systems, they have to all work together. You got different organizations that control them. Right? You may have a contractor that does all your pharmacology stuff. You may have another contractor that does all of your business process stuff. And then you may do your own in-house integration of all the medical devices and medical record keeping. Well, all of those really need to work together, right? But there are all these different people doing them. So part of what I'm trying to do is to take a systemic approach to that and say, how do you manage that? And how do you get visibility into what all those different people are doing? And this is one of the ways we're looking at trying to do that. I'm also trying to use multiple layers of Kanbans and doing some cool lean stuff with it, but that's another talk someday. That's still under research. All right, here's a way of saying, we talk about it as being a generator. Different risk patterns mean that you go through these phases differently. For example, suppose you've just got an ERP-based application that you're going to add to your own ERP system, right? Not an unusual thing that happened. So first you go through your exploration phase. You say, yeah, is this a big deal? No, we've already got it out there. All we're going to be doing is adding a function. So You go to the valuation stage and you say, is this still valuable? Is this a valuable thing to do? Well, yeah, because the boss said they want it and it looks like we can pay for it and it doesn't look to be too bad. So not a lot of risk there. Move into foundations. The foundations are there. The architecture is already there. You've got an ERP system that defines the architecture of everything you're doing. So you can go into development fairly quickly, like 1, 2, 3. On the other hand, if you've got a product development that's complex but feasible, you may need to do some of these a little differently. You may say, it's a risk, it's an acceptable risk if I look at certain kinds of things in the valuation. For example, I look out to make sure that there's nobody else doing this and that there is still a product, a need for the product or a need to meet. And so then I do that, I say, yep, that's acceptable. I go into my foundations. Can I actually put this on a platform of some sort? Do I have to build a platform? Does it still make sense to do this? Yes, okay, I will do that. Risk. And then you can begin your incrementally, if you want to do your minimal marketable feature kind of idea at that point, you can start doing that. So each time you're looking, is the risk acceptable or not? You're determining the risk is acceptable. And they're actually, we provide you guidelines on how you determine those risks and all that stuff. Although most of those this does require you to think. And unfortunately, management sometimes doesn't want processes or things about process that make you think, but these do. Because you're evolving not only the architecture and the system, you're evolving the process that you're using to develop the system. Okay, so at one stage you may change from a very constructive or a very predictive form to a very agile form, right? And you may go back and forth. You may have different pieces that use different kinds of systems. And let's go back over here. Here's a good one. We're in a situation where we're building a product. We've done all of our research. We got our stuff going. And we get ready to go to development, and somebody beats us to the market. Do we continue or not? Well, they're going to be like 5 times better than we are, even if we were to get it out today. Maybe not. Let's look for something else to do. That should happen more often, by the way. We should have more projects that unfail. I like unfail. In other words, if you kept going, you're going to fail. So unfail yourself and use those resources to go somewhere else and do something. Okay. We talked about evidence-based. This is a very quick list of the things that you need to do at these anchor points, the evidence. If you're familiar with RUP, these are the kinds of things that happen at the anchor point milestones at RUP. They came out of the same time at Embase, which was one of the USC things that came out. And this happens at each anchor point and is actually continually done. And what's nice is if you're building this evidence, and this is, I don't really talk about how you build the evidence, but as you build the evidence, you can actually get a measure of how close you are to the next milestone by looking at the amount of evidence that you have against all the risks that you're looking at and against your whatever your baselines are. So it's sort of like a cumulative flow diagram. You get your cumulative evidence. It makes a very good indicator. Of course, it's kind of not predictive because if you've waited till the very last to do the really hard stuff, then it can be a problem because then you get back to that 80%. First 80% takes 80% of the budget. The second 20% takes the other 80% of the budget. This is the incremental agility kind of part about this. And this is, I always call it the 3-layer management style. But basically it says for everything you do in an increment, you have a team that's protecting the increment from unforeseeable change. Right? So this is a little bit like the Scrum person, the Scrum Master keeping the management away from the team. On the other hand, it's much more team-based in that this is part of the team that's trying to plan the future increments. So it's capturing all of these things that are happening and hopefully also deferrals from these stabilized development. It may be that you actually have to go through, you've got something that's so important that you have to do it, and so they work that issue. But it basically keeps the short stabilized development increment, your tight teams doing good work, right? The high assurance part says that V&V is happening all of this time. So you've got this V&V layer that's happening. Again, this fits very well into Agile because you're doing continuous integration, hopefully. You're doing all those kinds of automated testing and things like that. And then obviously you've got a plan for those things that you are foreseeable change, but it's these unforeseeable change things that need to be dealt with. And then of course this gets as many as. And what's really cool, I don't think I put this diagram in, but these short stabilized developments can spread out, and they don't have to be in the same cycle, the same cadence. You can have multiple cadences going on for, suppose you've got a piece of software that's a COTS piece of software that has to be wrapped. Well, that piece could be going on over here. Then you have a whole new development of software going somewhere else. So its cadence may be totally different for various and sundry reasons. The COTS cadence may depend on COTS releases, right? You may need to wait for a new release of the COTS before you can continue the wrappering or whatever. On the other hand, if you're building hardware or you're doing some sort of microcoding or some sort of ASIC kind of work, that's going to have its own cadence going. So you can have multiple of these in a large complex system going on at the same time. And the cadences can be independent, but they need to then be mapped up and coordinated at some point. So at some point, be it an anchor point milestone or something else, you need to have these things come together because you need to do that syncing. Microsoft actually had a really good idea about that, where they always left certain cycles for syncing, or synchronization, so that all these various things happening could be brought together. Never let it be said I didn't say something good about Microsoft. Okay, actually, oh well, here we are. I did put it in. So you can have all these different things with different things going on. So you can stack this thing, rack and stack them as much as you'd like. The other thing I was going to say about this is that if you look at SAFE, it has a bit of this in it. There's a sense that SAFE likes to have synchronized cadences, but it's not a given. It just looks that way in the diagram, because Dean and I talked about that, whether he meant that or not, and he said, no, not really. Although I think he still likes that idea, because it allows for easier measurement. Okay. Again, the principles, and what I'm going to, a couple of examples here very quickly. This is the design award winning ICU infusion pump that they used in this National Research Council's Human Systems Integration report. Really cool thing. And one of the things, if you look at the things that were done in it that were right, they had a lot of interviews. They did a lot of competitive analysis. They did a lot of prioritization. They talked to the people who were going to be using it. They did safety and business risk assessments, all about this in the evaluation phase. They made sure they were going to proceed while they addressed the risks. They actually came up with a reasonable approach and an architecture for where they wanted to go that would allow them to increase over or at least to evolve the system. Then they developed it with a usability criteria, a lot of that. They did failure mode analysis stuff. They did patient simulator testing, all sorts of things like that. One that didn't work out so well, and I understand that the Oregon one didn't either work out so well. My own feeling is there's a reason for that, and it has nothing to do with the people building it. But I'm giving you a walk on that one. Here's what we thought, and this is actually out of the book, some ideas that we thought would have helped in things that didn't maybe get done. There were lots of stakeholders. They were numerous and powerful, and they were difficult to reconcile win conditions and success models. Now, I personally don't think you could have gotten one. I think politically there was there was no win conditions, because one side wanted it to win and one side didn't, and there seemed to be almost nobody in the middle. So where there is no negotiation possible, it's tough to decide. Some of them were not negotiated at all. Some of them weren't even investigated. And then there was no real shared understanding of values, assumptions, and expectations. And what happens if you don't have that common understanding of what success is you end up at the end blaming each other, right? Well, you didn't do this, but that wasn't a win condition. You know, that wasn't something I thought I was supposed to do. That wasn't anything. Anyway, so I think there's a whole bunch of value-based issues there. Commitment, incremental commitment. First of all, 5,000 pages of a law and 78,000 health plans. You want to, I can't write a 2-page letter without having contradictions in it, right? And I'm not a lawyer. I live in a town with a lot of lawyers, but I'm not. So there was no way that there wasn't going to be ambiguous and conflicting requirements, and no one had the authority that we know of to fix that. No one put together anything to say that. Top-level leadership didn't really have any significant experience in overseeing it. They had very little understanding of what commitments they were making, and also were politically driven to some extent. Development was set up as an all-or-nothing delivery date. I mean, you could have done it a different way. So there was no way of looking of coming up with a really successful road with a very low probability. And the expectations were set high, right? We didn't do the expectation management, which is one of the key things that you do, right? You never set them extremely high on something that you have no idea whether you're going to be able to do or not. Certainly, there were factors that concurrent multidisciplinary engineering was difficult. There wasn't a lot of obvious expertise in some of these things. There was a lot, but not adequate. And the supply chain communication was pretty weird. I mean, they really didn't have any sort of agreements or even an understanding of it before they did $600 million of contracting to 55 different companies. Now, I mean, my only feeling is they should have gone to Bezos and said, build this, right? I mean, if you can build Amazon, you could build this. But we didn't. And that's another political, that's a stakeholder issue. That's because you and I are people, we don't want that to happen, right? We want our tax dollars to be somehow maximized, and we don't want it going to Uncle Fred, who's, I don't know if you guys have seen the thing about the silencers. Has that made the newspaper here? There's some big thing at the Defense Department where this guy's brother-in-law got $1.5 million to build some untraceable silencers. You know, nepotism is not good in the government. Anyway, okay, schedule was a key driver, but it appears that there was no prioritization of key requirements, so you didn't know what to drop or incrementally roll out, and the risk associated should have led to what we would like to see, which is collaborative incremental development strategy, not a single deployment. Finally, he says, and I hope you guys are not too asleep. So what have we learned? Well, I think it's very clear that we need to bridge these two disciplines, and that it's going to get more important probably daily. I think it needs to reach out from both directions. I don't think either the systems engineering or the software engineering folks have all the answers, and I think they both have to learn from the other. I think there is deep experienced discipline out there. We just don't use it occasionally. We know what we need to do. One of the problems that we used to have on the CMMI stuff was that people really knew all the stuff that was in there. People just didn't want to do it. They just decided that they could cut the corners. Or they decided they would do just enough to get the number, and that was the other unfortunate thing with that. Guidance, we need to have a more holistic and flexible framework. The holism, I think, is important, as is flexible. I think it needs to be broad enough to incorporate all of the things that systems thinking allows us to bring in, but it also needs to be flexible enough for us to get feedback and to get that sense of steering a product rather than defining it and executing the plan. I think guidance exists to build this stuff. I think there's interested parties to invest in it. Certainly the Department of Defense was an interested party. I think larger systems people, hospitals, medical, education, there are all sorts of places that can use the kinds of things that we do in software all the time. I think there are myriads of workers beginning to work on it. I think all of you are doing something in this space. So feel good about yourself if you're doing something in this space, because you're doing things, you're doing the right things, I think. And my feeling is it's only going to get worse. And the crossing traffic on this bridge is going to get more and more complicated. And to do that, the bridge has got to be strong enough to hold that. So the foundations that we build and the superstructure that we build have to be broad enough to carry all of that material. So more information, this is the other advertisement. If you can come to the tutorial on Wednesday, that's fine. I've got about 10 of these books to give away to people who, if you want to come to the tutorial, you'll get. Or you can, buy it both in electronic or hard copy form. And then, I know I sound like a sales oil sometimes, a snake oil salesman, and I don't want to do that. So, questions. We've got, I guess, about 15 minutes for questions, maybe? 5 minutes for questions? Ooh, I took too long. I'll be around, so you can ask questions either. Yes, sir, down front.
So, the half-hour stuff, I understand, you make a separation between the development and the D&D on your diagram.
Mm-hmm.
And
Well,
that's what the diagram shows.
yeah, you're right. And I'll tell you why in a second, but go ahead.
And you also, unfortunately, although I used to work at Microsoft, I think the stabilization stuff, which is where they did the syncing, was actually one of the worst ideas.
Really? Okay.
It's this idea that you can have all this technical debt that you keep blowing out, and then you have this period of time when you try and recover the fact that you're not integrated earlier.
Yeah, no, I would not. I didn't see that as a technical debt issue, a retirement issue. I saw that as a synchronizing, make sure everything is going in the right direction.
You should be synchronizing continuously like all the other aspects of continuation. So that's why I don't understand the separate time when you synchronize. So could you address both of those concerns with what you presented?
Yes. If you look at that as three separate teams, it's probably more like one team with three independent roles that are constantly working with each other. The reason it got broken out the way it did was in many of the government environments, the people who are doing the V&V are not allowed to be part of the development team, right? So you're supposed to have somebody, and it's a good idea. And some of if you think about it, you want to have somebody that's not got ownership for the development that's checking it. The other thing was that you wanted to have that V&V done on the incremental product so that it might be a half a sequence behind even, and that it was making sure that the things that were done that were discovered in the last increment were getting dealt with in this increment. So there was this independent sort of chain there. So that's kind of where it was going. But it wasn't supposed to be that there was no communication there. There is communications up and back.
Right, but still sounds like a handoff rather than an integration.
Except that it was all done in the same cycle. It was all done in the same increment. All of these three things were happening at the same time.
That's good, but I thought you just said a second ago half an increment off.
It could be, well, yeah, because you've got, all right, so there's, again, it's the viewpoint that you're looking at. These guys are looking at, did you fix the things from the last to make sure that they were fixed? So there's a half connection there. They're also looking to make sure that you're doing right and doing the right things in this one. Where it really comes down is when you've got things like, if it's hardware, who's doing all of the wave soldering, making sure that the wave soldering, all the people that are doing wave soldering are certified to do that, and all those kinds of QA kinds of things as well. So there has to be some place for that to happen, and that doesn't necessarily have to be within the team, because you may not have that many experts, right? You may have to be rotating those in and out, which is why you like to have Kanbans there where you can prioritize where your experts go as well, which gets into a whole nother side. But yeah, it's a good observation that there is that separation, but it's more of a separation in focus. And send me an email about that. I want to think about that more though, how we can say that better. Other questions? Questions? Yes, ma'am.
It seems there's a lot of similarity in the risk management between this and the rapid learning cycles of lean product development. Is there a relationship between the two methods?
Not really. I mean, the lean product development would fit within this concept. I think the difference is that it would be a type of process that you would put into this framework. It's like SAFE is the same way. SAFE really doesn't deal with hardware. It doesn't really deal with upfront. You've got the architectural runway and you got that, but it's not quite as specific. Now, Dean's moving that out. He's getting ready, if he hasn't already put it out, a systems engineering version of SAFE, which I haven't looked at, so I can't say one way or the other. But again, that's a specific process. SAFE tends to be a specific process. This is a process generator that allows you to look at what's the risk of my using lean product development here as opposed to using XP or as opposed to using some other form of lean, Kanban with a capital K, which is David Anderson's stuff. Does that make sense? Okay, because it's not easy to understand. I mean, I have a hard time getting my head around the fact that I can change my processes and actually change my paradigms midway. But if you think about it, you almost have to be able to do that on some of these systems.
So rapid learning cycles is something you could be using to manage the number of design questions that are coming up across your hardware, software, people management.
Exactly, exactly. And all of those are, I think, captured in the principles of this whole idea. And the reason we don't say how long an iteration is, we don't even define really an iteration, other than that you have a little bit of a review at the beginning of Foundations. It says we know what we want to do in this. So in that way, it's very Scrum-like, or at least Scrum fits into it. Scrum doesn't look at risk particularly as intentionally as this does. Risk is huge with Barry, and I mean, he's lived through it, so he's very interested in the economic risk as well. Other questions? Yes, Michael.
Just one, and I think it's probably the last one, so someone else has one. This is a human factors question. I'd like you to repeat the question so they
Okay.
Based on my own experience, my wife and I did a whole risk analysis about deciding whether to start our own business. We did all these pros and cons, and we looked at the pros and cons and said, oh gee, doesn't really look like it's a really good idea. And then we went ahead and did it anyway.
Okay, question, oh.
There's a human political, and the larger the group, the more the political thing where making a no-go decision is really tough. Are there techniques or methods to help people do that better with the risk? And I'm speaking from, I don't want to do it again.
Okay, all right. So the question is that there was a personal discussion and lots of analysis done on whether or not to start a new business, and the analysis said it probably wouldn't be a good idea, but the people involved said yes, but let's do it anyway. I don't think that's a problem, actually. I think that's, you understand the risks, you understand that there's a large chance that what you're going to do is not going to work, but you're driven to do that because that's what you need. You are a stakeholder, and your win conditions are that this is important for you to do, not that you win. I mean, I think there are a lot of us that think about running a marathon. Many of us don't, like me, for obvious reasons. But there's the sense that you still could go train for one even if you don't run it. Now, it's not quite the same as that. But as far as tools, I think the win-win tools, there's a new version of it out that's not, I mean, it's available, it's free, you can get it from USC, but it's called WinBook, which is a Facebook kind of thing to do win condition collections and negotiations and stuff. And I think that was it. So unless there's another, I'll be outside at the break whenever the break is, hopefully now.